So let's look at this all put together. So we have our exp data type as before, and parse continues to produce it. But instead of expd now, we've just allocated some tags here. So our compiler is going to take exps, and it's going to create xd records in memory by allocating addresses for that content. Similarly, values, we don't have the value type anymore. We just have numbers that correspond to the different variants that we used to have. And for environments, the compile time environment, for compile time we'll still use Shplait things because it's interp that we care about being at the machine level. Continuations have tags, and the cons that we use for runtime environments has the tag 17. Here's our implementation of memory and allocation. So we have that memory array, malloc1 takes a tag and A and puts it in, and I'm using this inc pointer helper to bump the allocation pointer and then return the old value in each of these cases. So it turns out that we have 4 shapes that we need in our interpreter, malloc 1 through 4, and here's the implementation of that ref function. It takes a base address and then an offset, and it just looks in memory at the sum of those two things. Our interpreter function now takes expreg, which is not a record anymore, it's just an address. It looks in memory at that address and finds out if the expression there is a number expression, an add expression, a plus d expression, and so on. If it's a numd expression, then the literal number is inside that expression at offset 1. We take that number and we put it in a newly allocated record with tag 15. That is the int v tag. We get that number back, and that is our value register, and we continue with it. Similarly, in plus d, we need to allocate a new continuation record, and we use malloc 3 for that because the relevant continuation has 3 fields in it. At this point, the only thing that looks like a function call are things like ref. And remember, ref is really just looking inside of the memory array, so that corresponds directly to a base address plus offset kind of instruction at the machine level. We have these functions like malloc2 and malloc3 that really are functions, but they're all short functions. So they could all be just inlined and avoid the function calls there. These calls to interp and continue take no arguments and have nothing after them, so they can be implemented just by jumps. And even in the case of @d, where we used to be used listref, now we write our own mvref function, which, just like interp and continue, has no use of Shplait's continuations because it either calls itself for a recursive call or it calls continue once it found the value that it's looking up. So we have completely weaned ourselves from function calls and from continuations at the Shplait level, and we have something here that's really close to just assembly code.